Okay, so we're continuing on with sum of the parts equals the whole. And we're just going to look at this little itty bitty another example here with the line segment. Oh, okay. There we go. Here we go. There we go. So, if I have a line segment, I have line segment AC that's cut into pieces. There's point B not in the middle, but there's point B that does cut it into two parts. So, by this idea of sum of the parts equals the whole, if I take AB, those highlighters are just so extra, like, whatever. And then BC, AB plus BC gives me the entire AC. The sum of the parts equals whole. Sum parts equals whole. That's going to be the key sentence here that you're writing to explain and to show work when you're doing these problems. Okay, so let's take a look officially at this example one. And again, when you're doing this, you need colors, crayons, markers, colored pencils, whatever you have, different colored pens even, whatever you've got available to you to kind of mark up these diagrams, because that's your biggest, that's the best tool you have. So if the measure of angle PQR is equal to 4x minus 2. So I'm going to go ahead and mark up my diagram right away. Angle PQR. So PQR, that's this angle right here. So 4x minus 2 is that angle right there. That opening between those two rays is the angle measurement. Then they give us the measure of angle Q or RQS. So RQS would be this guy, which would be 5x minus 8. And then, last but not least, they tell us that the measure of SQP, which is the entire angle, that entire angle. So I'm going to do a giant little red mark here. It's not little, it's big. And mark that as 10x minus 19. So those, we don't know. I want to talk about something for a second here. We don't know that angle PQR and RQS are equal to each other. And they're actually not, because 4x minus 2 and 5x minus 8 aren't going to be equal numbers whenever x is. We can't assume that those pieces are equal unless there's a real life midpoint there or something that they tell us about. So this is a sum of the parts equal the whole, right? They give us the two parts and they give us an expression for the whole thing. So I'm going to use that to create an equation. The explain part comes from that little sentence that I said right here. You're just going to be writing that down. So let's go orange. So remember, sum of parts equals the whole. So sum of the parts. 4x minus 2 plus 5x minus 8 is equal to the whole thing, which was that 10x minus 19. It seems a lot easier to put it together after you've marked up the diagram, and you just have to mark up that diagram because then you have a visual of it and it just makes more sense usually. So now we're just solving here. 4x plus 5x is 9x, negative 10, 10x minus 19, oops. So let's plus 19 to both sides, 9x, 19 minus 10 is just 9, plus 9 equals 10x, minus 9x to both sides. 9 is equal to x. So x is equal to 9. All right, now again, just making sure that we've answered the question here. They were asking me to explain the measure of angle RQP. RQP is the same as PRQ. It's just written backwards. They just have the numbers or the letters backwards. So, oh geez. There we go. So we're going to use that expression 4x minus 2 to find the measure of angle RQP. First, I think we should write a quick little sentence that says the measure of angle RQP is equal to the measure of angle PR or PQR. Those are the same angles, just written backwards. So the measure of angle RQP is equal to, and I didn't write that big enough or small enough, is equal to 4x minus 2. And I now know that x is equal to 9, so I'm going to use that. 4 times 9 minus 2. 9 times 4 is 36. 36 minus 2 is 34 degrees. So the measure of angle RQP is equal to 34 degrees. And there is your first example. Again, it's important that you've got this little explanation piece about the sum of the parts equaling the whole. That is where you get that explained from.